Hi, it's Adam. I'm a software engineer at Zoo, the company making the Zoo Design Studio, which is a brand new CAD tool. Today we're going to be looking at how to make interesting sketches in Zoo. We're going to be using KCL, the Kitty Cat language. This is a programming language we wrote that is designed to make CAD models. Most programming languages output a piece of software. This programming language outputs 3D models for your CAD systems. So you don't have to use KCL to use Zoo, but you can if you want to. And this video series is about teaching you how to use KCL. So in the previous video, I kind of walked you through going from 0 to a extruded triangle. So if you haven't used Zoo before, I recommend starting with that video. That kind of walked us through the basics of how Zoo Design Studio works and how the very basics of KCL's language work. So in this video, we're going to be diving a little bit deeper into how to make interesting 2D sketches. And then the next video, we'll look at how to turn those 2D sketches into 3D sketches and what you can do with them once they're there. So let's start. We're going to make a new project. We'll call this Interesting Sketches. So like I said, Zoo has its own language called KCL. We're going to be coding in KCL. KCL, you write KCL in this little box here, and you'll be able to see the visuals being rendered in the main part of the screen over here. So let's get started. We first start sketching on a particular plane. We'll use the XY plane just for now. And then you can start sketching at a certain point. This is called a profile. A sketch has 0 or more profiles, usually one profile, otherwise there's no point having a sketch, right? So we're going to start with, we'll start at the origin, 0, 0. And we've got, first up is the basic line. So line has there are two ways you can use line. You can either tell KCL to go a certain direction along X and Y. So let's say go 40 units along X and 40 units along Y. That's what the end argument does. This end means it's a relative distance. You're going a line whose end is 40 distance along X, 40 along Y. We can make it go, negative 40 along Y, and then it'll flip the direction. Let me just expand this so you can see it a little bit better. And let's just move the camera a little bit so that we're on the right angle. Again, like I said in the previous video, you can use these little axes to choose the exact angle that you're looking at. So, yeah, okay, I'm just going to move this so that it's rotated the right way. Cool, okay, there we go. So, end takes a relative distance. This means you can say, let's go 10 along the x-axis. And then I can copy and paste that and say, let's go another 10 along the x-axis and another 10 along the x-axis. So each time you're moving 10 relative units. Then you can also use end absolute. Instead of taking a distance, this goes to an absolute point in the grid. So I can say, if I say, let's say go another let's say go 10 back along the x and 10 up. That's going to move us backwards along x, up along y. But if I said end absolute, then it takes an absolute point on the grid. So this is saying go to x equals negative 10 and y equals 10. Before, these are saying move along 10 units, and end absolute is saying go to this specific point. So end means go a certain distance along, and absolute means go to a specific point. This kind of technique of using relative directions versus absolute points is going to come up a lot. So keep that in mind. So we can sketch out a basic square if we want. We can say go 10 along X and then go 10 along Y, then go negative 10 back along X and negative 10 back along Y. And then we see our square being rendered here. So that's cool. We can simplify this if we want. Firstly, because we know that these should all be the same length to make square, we can define a variable. We can say, side equals 10, and then I'm going to go through, I'm going to do a find replace and replace all the 10s with side, except for this one up here, which should stay as 10. And by doing that, you have your length defined in one place and one place only. So now if I want to say make this bigger, I just have to change one place. And now it'll be twice as big. And if I want to make it bigger again, it'll be one place to change it. If these were all units here, it would become much harder because I'd have to go through every place and change them all. So that's one way to do it. Now, we have a lot of other functions besides just lines. Firstly, you can use xLine. Like if you know that your line is supposed to go along the x-axis, instead of doing this, let's comment this line out, and we're going to replace it with xLine. Length equals side. And you can see it's the exact same because xLine says draw a line parallel to the x-axis along with this much length. So over here we can replace this one with xLine, and we can say its length is negative side now, because it's going to be going back towards the other direction. So negative length is like a length in the opposite direction. Okay, cool, we've got our square, it's still looking good. There's obviously a y-line as well as an x-line, so we can put over here, we can replace this with an equivalent of y-line, where the length side, that still looks the same as we expected it to. And then we can also replace this one here with y-line where length equals negative side. Cool. Okay. One nice thing about this system is because we've used relative distances, we're using length, it means that we can change where this profile starts, and the shape itself should still be the same. So we can change this to start at 10, 0, and the square itself remains the same. We can change this to be 100, 0, and it'll shift around. Let me just zoom out and find it. There it is. But it's still the same square shape, right? Because all of these lengths are relative. It doesn't actually take in specific coordinate positions. If it did, this would change. Let's see an example. If we change this, let's put this back to 0. If we change this to say, let's go, and absolute equals side. So we're drawing a line. Now we're saying draw an x line that stops. We've rotated it the wrong way. Now we're saying, draw an x line that stops at 40, right? At x equals 40. Now if we change this, let's say we started at 20, the line's going to half in size because it's now going from 20 to 40, right? Because this has stayed the same. We're saying go to the exact x position of 40. Right, now you see if I put this to 39, it's going to be only 1 little millimeter wide, so tiny little line here. If I put this up to, but if this was length equals 40, the line would still have length of 40, it would just be starting at 39. So relative distances are usually going to be easier to work with than absolute distances. It's not always what you want, but usually you should try and use them more because it lets you change the position more easily. Okay, we've looked at lines, we've looked at x lines and y lines. Let's see what else we can think about. Let's think about some other things. We have angled lines. So we can put in here, let's do an angled line. We're going to start by having an angle of, say, 30. And the length will be, I don't know, 100. Okay, it's telling us we forgot to put in our start profile at. I'm going to start profile at 0, 0. But let's name this point. Let's call this origin. We'll put up here origin equals 0, 0. Remember in KCL, these square brackets, this is an array. And an array of length 2 is a 2D point. So we can see here it drew an angled line of angle 30. So we should rotate the camera a little bit because I think it's making it confused. Where did my line go? Don't have very good Wi-Fi here, so it sometimes disconnects from the zoo engine. There we go. Let me rotate it so it's the direction I expect it to be. There we go. Okay. So we've now got our line of angle 30. So basically it's saying that, if you can imagine drawing a circle, this angle is 30. So if we put in an angle of 0, that's a better way to illustrate it. Let's say this angle is 0. This is an angle of 0. We can put it to angle 45. It's now an angle of 45. We can put it to angle 90. And these are all relative to the plane you're working with. So, if we flip the plane, doing the negative xy plane, in this particular case, it stays the same. But anyway, so we can use this to easily make shapes. Like let's say we want to make a pentagon, right? I'm not exactly sure of the math to make it, but what I do know is that the 5 angles have to sum up to 360. So let's say, let's define angle ang equals 30 divided by 5. In fact, let's say num sides equals 5, and we're going to make this 30 divided by number of sides. So we can then have an angled line. We're going to say let's break out the length somewhere. L for length. L equals 100. We're going to make 5 angled lines. I'm going to choose the angle of ang. So we're going to have ang. Well, I guess we'll start with 0. 0, ang times 2, ang times 3, ang times 4. Cool, so now we've made a pentagon. Now if we change this to be a hexagon, we just need to change this and add one more side. Cool. Awesome. And of course you can use the close call to close it off into being a 2D shape, not just a particular kind of arrangement of lines. Okay, so that's angled line. There's a couple of other ways to use angled line. Like you can have, there are other options you can set. If you mouse over it, you see there's a whole bunch of other options. Like you can say go a certain length along the x-axis or a certain length along the y-axis. And you can also give it an absolute point instead. But generally, I find this is the main way I use angled line. Okay, so we've looked at different ways to make straight lines so far, but what about using curved lines? Well, let's keep starting at 0, and let's get rid of these. So let's make a little straight line. We'll have a y line. Let's just say length equals 100 again. So we've got our line that goes along the y-axis, and now I'm going to use a tangential arc. Tangential arc, and let's say that its end will be, I don't know, what kind of distance should we move? Let's move 100 along r, 50 along the x, and 0 along the y. So we've now made an arc. It's an arc that starts where this line starts, and it's tangential to it, so it means it proceeds smoothly from it. Let's remove the close calls so you can see them a bit more easily. Here's our original line, and then here's the arc. You can see the arc moves smoothly from this angle, so it's tangential. And it's moving 0 along the y-axis and 50 along the x-axis. So we could change this to move along the y-axis as well. We could say, move 50 down the y-axis too. And again, it needs to take this kind of smooth tangential arc. So it's cutting out part of a circle as we move to a certain point. And from there, we could do a line back to the start. We could say line and absolute equals origin, going back to the origin we started at. We could also instead just go to the start of profile, the profile start. And that way we don't have to reference the origin a second time. We can just say, hey, wherever this start was, whatever the profile started, just go back to it. Cool. Tangential arcs are pretty useful. There's a couple of other ways you can use them too. And instead of giving an end point, you can also give a radius and an angle. So let's say we're gonna draw for our tangential arc. We're gonna have a radius of, I don't know, let's say 50, and an angle. Let's say we go out in this circle of length 50. We're going to do an angle of 90. So you can see here it's it's taking our line, and we're drawing a circle of radius 50, and we're moving to the angle 90 along that circle. So that's another way to use tangential arcs. We can put another one there and kind of loop around again. Let's say tangential arc, we're going to move around the same circle let's say radius equals 50, and this time we'll go to an angle of 180. So we go another way around, and then we can maybe move just a little bit more along it. Let's say move to the angle, I don't know, 200. It's kind of a bit too big from what I was thinking. Let's move an angle of 20 along it. Yeah, because 200 would be... These are all relative angles, so it's saying advance 20 along. It's not saying go to the absolute degree 20. So we'll now, yeah, we can just loop back, I guess. Loop back to the start. Cool. So another way we can kind of illustrate what this tangential arc call is doing is let's just start again. Let's just erase this and we'll start again. Yep, we've got a point, and let's just, let's move a little bit around. We're going to do a tangential arc. We're going to move 180 degrees around with that certain radius. And now let's move another 180 degrees, another half turn of the circle, but in a larger radius. Interesting. So you can see we've kind of got maybe a bit of a spiral starting to happen. And in fact, we can keep doing this again and again and again. We're going to make it 1.2, and 1.3, and 1.4, and 1.5. And the spiral gets bigger and bigger and bigger every time. So this should hopefully demonstrate how tangential arc works. It's saying every step we're going to be turning 180 degrees further around the circle, but then we're going to take larger and larger and larger circles every time. So it slowly becomes a bit of a spiral. This isn't really practical for mechanical engineering, but hopefully this should help demonstrate a little bit better how tangential arcs work. Another kind of thing we can do is we can just do a circle, right? There's a circle call that's very easy to use. We can just say, where should the circle be? Let's put it center at, sure, 3.4, 3.4. Let's bump up the radius. Let's make it a circle with radius 200. Nice. So really easy way to make a circle here. Okay. Yeah, I think those are the main kind of lines you'll want to use. There are some other ones. You can have, there is a specific arc call. This is not for tangential arcs. Let's just make a line. Let's start with a line of length 100. Oh, need a start profile at. Let's make a line of our given height. And let's think, okay, yeah, let's make an arc call. So arc is a little tricky. You want to set an angle to start and end, and the radius. So let's start the angle of 0, end at 90, and the radius will be, I don't know, a circle of 50. So here we go. Let me adjust the camera. So we're starting from an angle of 0, and we're moving 90 degrees along. And you can see that we could move, differently. We could move 135 degrees instead. That's going to move it greater area. Going to give us a nice top-down perspective. But we didn't have to start at the angle of 0. We could start at the angle of 90. And that's going to make a very, very sharp turn. So this is obviously not a tangential arc anymore. Right? If it was a tangential arc, you would be seeing, it would be at a tangent. It would be smooth and kind of advancing at a smooth angle. So if you want to have a non-tangential arc, like a sharp, pointy corner, the regular arc call is what you want to do. Right? This is basically saying, say this starts at 90, and we're going to move to 135. So these arcs can be tricky because you can build invalid curves. And then from there, we can then add a new line. We can say line where the end is going to be 50 along x and 0 along y. So you can see we've got this sharp turn here. And then we can do another sharp turn, another arc. And then let's move back to here and then up. So let's say move back along X, and then we'll move some degree up the Y-axis, and then we'll just say, then then go back to the start. So there we've made our weird shape. Okay, then we can close it off. And there you have it. So we've looked at lines, which are kind of basic bread and butter. They can go relative distance along the plane, or they can end at a certain point. We've seen xLines and yLines, which are a useful simplification in the event that you have a line that's only going along the x or y axis. We've seen tangential arcs, which are really useful for making nice smooth edges. Normal arcs, which are useful for sharp points, pointy corners. And yeah, we've seen how to go back to the start, just using a line where the end absolute is profile start. And of course, we've seen circles. So yeah, that is a guide to how to sketch some interesting kinds of lines and shapes with KCL. In the next video, we're going to talk about ways to make these 2D sketches into 3D objects, and what you can do with those 3D objects once you've made them. So stick around for the next one. Thanks.